Hello, I'm Steve Lewis. Welcome to the first lecture in Applied Statistics for Healthcare Data Analysis. This course is funded by a grant from the United States Department of Labor and uses a curriculum developed by Carnegie Mellon University for its course in statistical reasoning. The materials are found on the Canvas page for this course under the Syllabus tab. Before we get into subject matter, I'd like to make a couple of observations. First, this is definitely an introductory course and there's no prerequisite for a familiarity with statistics. You are expected to have a basic familiarity with algebra, but the good news there is that nowadays most calculations are conducted using software, so you don't need to spend a great deal of time and energy crunching through the mechanics of mathematical calculation. That leads to the second point, and that is you are able to focus on the much more important considerations of ensuring that statistical analysis is built into the basic design of any study or investigation. I can't tell you how frustrating it is to be handed a bundle of paper by someone who says, "I conducted this survey. Tell me what the results mean." The course materials also strongly emphasize the importance of identifying what research questions you want to answer, identifying what statistical analysis tools can lead you to answers to those questions, what kinds of data you need to withdraw from the population of interest in order to utilize those tools, all of those elements into the design of your investigation. The course lays out a four-step model of statistical analysis. From the population of interest, producing data, which in the second step are subjected to investigational or exploratory analysis to produce descriptive statistics, application of the principles of probability, and from the data, drawing inferences about the population. These are illustrated in the big picture graphic in the introduction to the course. You'll notice that in the organization of the course, the first two steps in the process, capturing or producing data and exploratory analysis, are reversed. This is counterintuitive, but I think it actually serves a useful purpose. By talking about what you do with data, it helps give a sense of what criteria the data have to meet, what quality and kinds of data you need in order to do analysis. So even though it is counterintuitive, I think it's useful to do it this way. The discussion then in this first section on exploratory data analysis introduces the concepts of different classes of variables to be analyzed. It makes a distinction between categorical variables, like the on and off status of a light switch, and quantitative variables, like temperature. It also makes the distinction between what are called explanatory variables, which may be markers or predictions for the behavior of another variable, and what are called response variables, variables whose values may be predicted or indicated by the values of another variable, the explanatory variable. It also introduces the idea that the values associated with a particular variable may distribute themselves over a continuum. Whether we're talking about the values of a proportion, the percentage of emergency room visits, for example, that are preventable by appropriate primary care, or a mean of a distribution of a quantitative variable. In general, We deal with proportions when we are talking about categorical variables, and we deal with the mean of a distribution of values when we are talking about a quantitative variable. You'll also be introduced to the concept of the standard deviation, which, when we're talking about a distribution of a variable, is the average distance any one value is from the average or the mean value for that distribution. And you'll also be introduced to the standard deviation rule, which says that a predictable percentage of the events or the values for a variable fall within a given number of standard deviations above or below the mean. This concept will become very, very important when we begin to talk about probability. Finally, there is a section in this first unit about linear regression. This is the general concept of correlation, the extent to which values for one variable track with values for a second variable, either positively or negatively. This is probably the most mathematically heavy portion of the course, and I would not encourage you to spend a great deal of time working on the regression calculation component. Rather, I would encourage you to think in terms of the degree to which two variables relate to each other. How closely do they track each other, either positively or negatively? How linear is that relationship, and how strong is that relationship? Those concepts are what we will actually be using later in the course in discussion. So this first unit, the unit number 1 of the Carnegie Mellon curriculum and module number 1 of our course syllabus, is rather extensive. It takes up over 60 pages of text, but it, I think, forms a clear picture of what we are going to be wanting to look for as we talk in the next unit about what is required to capture data and what those data need to be able to accomplish. So I look forward to seeing you next time. Thank you.